In this video, we're going to look at a topic that's a little bit related to composition of functions. It's looking at more general ways of finding average rates of change. So we're going to review the definition of average rate of change, and then we're going to demonstrate two methods for finding many average rates of change at once without having to do computations over and over again. So first, we're going to remember what the average rate of change is. F is a function. The average rate of change of the function f between x equals a and x equals b is you find the outputs at a and the outputs at b and subtract them. And then you find the inputs of a and the inputs of b and subtract those in the same order, and then you divide those. So what we have been doing so far with average rates of change is we have two specific points and we find the average rate of change between them, and that's fine. But there are situations, say if we wanted to find lots of rates of change around x equals 2, if we wanted to find 10 different rates of change, that can be very complicated computationally and tedious to do those computations. So we're going to find some more efficient ways of doing those in this video. So first method is, well, I want to find a bunch of points around x equals 2, y equals f of 2. So one of the points that we're going to be really concerned with is 2 f of 2. But we want to say maybe be worried about many other points that are around that. Well, we don't exactly know what those points are. We want to be very flexible. So we're going to let the other points kind of be at x equals b. So we're going to say x equals b, that represents all the other points. So b can have lots of different values. And if that's the case, then b is going to be the x-coordinate, f of b is going to be the y-coordinate. And we're just going to keep it b for now, and then if we actually want to find an average rate of change, we'll plug in an actual value for b. So our average rate of change then becomes f of b minus f of 2 over b minus 2. Now another way we can do this, and it's not a better way or a worse way, it's just a different way. We can have our same point 2 f of 2, and instead of expressing our other points as x equals b, we can express our other points as x equals 2 plus h. So that seems a little bit weird, but here our point is going to be x equals 2 plus h, y equals f of 2 plus h. Now this seems a little bit strange, but you can think of h as the difference between the 2 points. Your one point is 2, your second point is 2 plus another number. And so when we find the average rate of change, what do we get? Well, we're going to subtract the y-coordinates to get f of 2 plus h minus f of 2. And then we're going to subtract the x-coordinates to get 2 plus h minus 2. And one thing you might notice in that denominator is the plus 2 and the minus 2 will cancel each other out. And you end up with f of 2 plus h minus f of 2 all over h. So let's try this on f of x equals x squared. And we're going to find all the rates of change around x equals 5. So x equals 5 is going to be one of the points we're looking at, and then we're looking at as many other points as possible. So method 1, we're going to let x equals b, and f of b is equal to b squared. So that means, and then f of 5 is equal to 25. Those are our two outputs. So our 2 points are going to, our point is going to be b squared, and 5, 25. And we're going to find the average rate of change between those 2 points. Not a big deal. We subtract the outputs, we subtract the inputs, and there we have our expression. And actually, there's nothing inherently wrong with that expression, but one of the nice things we can do with this expression is we can simplify it a little bit. It's kind of hard to see, but if you look at the top, the numerator, we can take that b squared minus 25 and factor it. B squared and 25 are both perfect square. You have b squared minus 5 squares. And then we know how to factor perfect squares. That becomes b plus 5 times b minus 5. And the thing you might recognize there is that now we have a b minus 5 in the numerator, a b minus 5 in the denominator, which means we can cancel those two. And we end up with just plain old b plus 5. And b plus 5 is a really easy quantity to do computations, right? If your b is 7, you just do 7 plus 5 is 12. If you do b is 12, 12 plus 5 is 17. Whereas doing all the computations with squaring and subtracting and dividing, that can be rather complicated. One thing I do want to note is the b squared and the 5, 25 actually have to be different points for this average rate of change to make sense. So in order for this b plus 5 to be a legitimate formula, a legitimate expression, we have to have b is not equal to 5. That's just because if we put b equal 5 into the original expression for the average rate of change, we'll get 0 in the numerator and 0 in the denominator. And dividing by 0 doesn't make any sense at all. All right, so let's try method 2 now. So now we're letting our 2 points be x equals 5 and at x equals 5 plus h. So when we plug in 5 plus h, we get, well, we're going to get 5 plus h quantity squared. And we're probably going to end up squaring that sucker out anyway, so let's go ahead and do it right now. So we square the 5 to get 25. We multiply 5 times h and then double that to get 10h. And then we square the h to get h squared. And then f of 5 is, of course, still 25, just like it was before. So our 2 points are x equals 5 plus h and y equals 25 plus 10h plus h squared. And our other point is 5, 25. And now we find the average rate of change just like we did before. We subtract the outputs, the y coordinates, 25 plus 10h plus h squared minus 25. Then we subtract the x coordinates. We get 5 plus h minus 5. And the 5's cancel to give us just plain old h. And notice in the numerator, those 25's are going to cancel. And now notice that in the top, we can actually factor it. We have a common factor of h in both terms, so we can actually factor out an h from both of those. And notice now that those h's are able to cancel each other from the top and the bottom. And so we end up with 10 plus h. Again, really easy to do computations with that, right? If your h is 2, you get 10 plus 2 is 12. If your h is 3, you get 10 plus 3 is 13. You get what you can put in different values of h, as many as you want, and do those computations pretty easily. Now, the other thing I want to direct your attention to is, again, looking way to the left at our original computation, our h is in the denominator. So we can't have an h that's equal to 0 because dividing by 0 is not allowed. So even though 10 plus h seems to be okay if we put in h equals 0, we can't do that because dividing by 0 is not allowed. So we put an extra condition. Remember, don't put in h equals 0. So h is not equal to 0. All right, so that gives you an introduction about how to do general average rates of change. You're now ready to work on the in-class activities. That's on the PDF file included with this video, and it is called General Average Rate of Change.